We now want to look at how to solve a quadratic inequality. Now, before we try and solve an inequality, it would be good to review at least one or two techniques for solving an equality, because we'll need to be able to do that. Now, our first equality is x squared minus 5x plus 6 equal to 0. The easiest way to solve this, if you're going to do it by hand, is to do it by factoring if that's possible. Since it's a trinomial, we'll attempt to factor it into two binomials. The x squared will factor as an x and an x. The 6 is a 3 and a 2, and then a minus minus. As you can see, that multiplies to give you plus 6 on the end. It adds to give you a negative 5x. Now I want to set each one equal to 0. I get the two solutions. Now, graphically, what is implied here, what we should see if we graph this, is a parabola that hits the x-axis at 2 and at 3. Now we can go to the calculator. I've already got the x squared minus 5x plus 6 put into the calculator. I can graph it, and we do see the parabola that we expected to see, even though it wouldn't hurt to have a slightly closer view. And as we graph it again, we see a parabola hitting the x-axis at 2 and at 3. Now what this parabola has done is basically it has taken the x-axis, which is the horizontal axis, and it's cut it at 2, it's cut it at 3. Now again, you know here that you have equality at 2. You know that you have equality at 3. So what we have to wonder is what's happening in these three intervals that are away from the 2 and the 3. And in those intervals, what's happening is either a greater than or a less than relationship. Now graphically, we can kind of predict which is happening. Looking at the graph over here on the screen, we see that when we're inside that interval with our trace option, we've got negative y values going on. If we move up far enough, get past the 3, see what happens. When you get past the 3, you can see positive y values showing up. So what must be happening is that when you are below the x-axis, you're dealing with negative y values. When you're above the x-axis, you're dealing with positive y values. So the two zeros have cut the x-axis into negative and positive y values. So if we had an inequality, let's say we have x squared minus 5x plus 6 being, say, less than 0, we could pick a number and we could test our intervals, which is really the easiest way to do this is just by the testing of intervals. We will pick a number in this interval, say 0, and we will go test it on the calculator. We will say 0 squared minus 5 times 0 plus 6, and we get a positive result, which means since 6 less than 0 is a false statement, that interval does not work. So let's try the next interval. In this interval, we could test a 2.5. We put in 2.5 square minus 5 times 2.5 plus 6, and we get a negative 0.25. Now since negative 0.25 is less than 0, that means that interval works. Testing the last interval, we could work with a 4. We would say that 4 squared minus 5 times 4 plus 6 is a 2. And since 2 greater than 0 is a false statement, that interval doesn't work. So we had 3 intervals. We tested them one at a time, and we found this one in the middle to work. So we can write the answer to this inequality in an interval notation. We will say the solutions fall in the interval from 2 to 3, and we will not include 2, we will not include 3, because this didn't say or equal to. And remember, the 3 and the 2 are a result of equality. So what this gives us is a basic strategy for testing and finding, therefore, the solutions to these quadratic inequalities. Let's try another quadratic inequality. If I get a new piece of paper here. Next example, we're going to go with x squared plus 10x minus 24 and make that greater than or equal to 0. Now, again, to solve the inequality, I've got to work with x squared plus 10x minus 24 equals 0 first. So I'm going to try factoring this. X and x gives me the x squared. And I believe for the 24, we're going to go with a, let's see, a plus 12 and a minus 2. So let's see, multiplying, that gives me my negative 24. Adding, that does give me my 10. So there, that works. So I've got an x plus 12 equaling 0, x minus 2 equaling 0, x equals negative 12, x equal positive 2. Now that's the equality portion. So what we know is that the real number line has been cut at negative 12 and at positive 2. So I've got 1, 2, 3 intervals to check. Down here in this interval, we'll go with negative 13. So we go to the calculator. And we're going to test negative 13. So that means that in parentheses, put negative 13 square, and then plus 10 times negative 13, and then finally the minus 24, and this gives us a result of 15. So is 15 greater than or equal to 0? That's the question, and it is. So that interval has checked out as working. In this interval, we can test 0. So back to the calculator. We'll put in a 0 square plus 10 times 0 minus 24, and that gives us a negative 24. So is negative 24 greater than or equal to 0? And the answer is no. So that interval does not check out as working. Up here we might test a 3 or a 4, maybe a 5. Again to the calculator. We'll put in a 5 square plus a 10 times 5 minus a 24. That gives us a 51. Is 51 greater than or equal to 0? And it is. So that interval works. So this answer is different. Last time our answer was the interval in the middle. This time it's the intervals on the end. So the way we would express our answer is negative infinity, which is down here at the left, to negative 12. Now since this was an equal to, I'll put the square bracket on to include the 12. And we'll run from 2 to positive infinity. Remember, our intervals work around our zeros that we found, not around the points we tested. So that example shows 2 separate intervals for your solution, whereas the last one was one single interval for the solution. Now, with these problems, you can have situations where you have all real numbers for a solution, or you can have no solution at all. That is actually possible. As a matter of fact, if we had x squared minus 14x plus 49, and we had that set as less than 0, we would go over here and we'd check the equality first. X squared minus 14x plus 49 equals 0. This factors, and if it'll factor by hand, that's the easiest way to solve. X and x, 7 and 7, minus and minus. And we found ourselves to have a repeated root. So x equals 7 is the only 0. So this number line will only be cut into 2 pieces. All right, over here on the left-hand side, I might try to test a 0. And this one I think I can test by hand pretty easily. 0 squared minus 14 times 0 plus 49 would be 49. And is 49 less than 0? No, it's not. Next number we'll test, it will maybe be an 8. And I might do that one on the calculator. Clear out what we had. And we'll go with 8 squared minus 14 times 8, and then a plus 49. Our result is a 1. So is the 1 less than 0? No, it's not. That fails. So your two intervals have failed. Now 7 was a 0. If I had said or equal to, 7 would be my only solution. But since it doesn't say equal to, for this one I have no solution.